All right, students, welcome back. So today I'll be doing a new chapter on differentiation. Okay, differentiation used to be in Form 4 chapter, but now they shifted it to Form 5. But the content I see is much of the same lah. So I will teach you. I'll try to break down my video in smaller chunks this time lah, to see whether it's better and it's more systematic for y'all or not. All right. But I will keep them in a playlist so you can actually see them correctly. And then one change I made to my notes is that I try to include solution spaces as well, because I realized before this, right, my solutions are very messy and I simply write everywhere, then I don't track them. Okay, I don't keep them. Basically, once I write, I erase them. So it might cause some trouble for some of you. So one good improvement I made is that I include solution space. If not enough space only, I think what to do lah. Like as in like this space is not enough for this question, then I see what to do. Then as I mentioned, timestamp is in the comment section below, or in the, it's not in the comment section below, yeah, it's in the description box below. Okay, just refer to the timestamp there for easy referencing to wherever you want to teleport to. Okay. So differentiation, let me give you an overview. Differentiation is a chapter where people fear a lot also, right? People tend to say that differentiation and integration are one of the hardest chapters in the entire Form 4 and Form 5. But if you trust me enough, right, differentiation can be the easiest chapter. In fact, to me, right, it was even easier than a lot of the chapters. Differentiation to me is easier than vectors. It's easier than solution of triangles. It's easier than most of the chapters, even indices, logarithm, trigonometry. Differentiation to me is one of the simplest chapters. Why? Because I know what are the steps to take me to do well in differentiation. And it's really there, you know. I don't say it for the purpose of convincing you so that you study well. No, it's because it's true that if you do enough practice and you see enough kind of questions, it will be very, very simple. Okay, so I divided the chapter into few parts. I divide them not necessarily were based on the syllabus, but I will cover everything in the syllabus, that's for sure. I'll cover everything in the syllabus, but I might arrange them according to how I would like to arrange them, how I want you to learn, okay? Which I think is most beneficial to you. So I've divided them into, first of all, I'll do 2.1. 2.1, what we'll learn is we'll learn about concept of limit, first part. Second part is I'm going to teach you the understanding on what actually differentiation means. And this is the main part of the whole chapter. Once you know this part, once you understand this part, right, you can roughly know the whole chapter, what is it all about already. But for this part, some of the students tend to not understand this part well because they see a lot of funny symbols. They see this delta, they get scared. You see, you know? And then they tend to get scared now when they see stuff like this. Before they even really try to understand, they already shut their door to understand this stuff already. So there's no point, okay? And then how this delta y delta x gives you dy dx. I'll teach you what is dy dx. Everything I'll do in 2.2b. And 2.2c, we'll learn first principle differentiation. Basically, the long method to do differentiation. First principle means you use the definition, not necessary definition, because you don't learn the definition. But in other words, you actually are using the traditional way. It's something like the first principle is basically something like the proving way to do this question. Okay, basically you're doing the long way. Like it's a very long method. You're not using the shortcut. Basically, you're following step by step using the understanding way, not using any formula or memorizing. Okay, no formula. You're just applying certain things to get what you want to get and get the dy dx. You're not applying formula like power rule, product rule, quotient rule, chain rule, whatever rule. Okay, you're not applying any formula. You're using the long method. This is called first principle. Actually, there's one more way also, using definition. Definition, I don't think you learn. It's something similar. So you actually have the definition for this differentiation as well. Okay, so as I said, I'll try to divide the chapters into maybe I'll do 3 different videos for these 3 different parts, so that you can know where maybe you're good in concept of limit, you are very good in limits, you just want to understand what is differentiation, then you can just skip to this part, you get what I mean, in a different video. so that the video won't get too long. Then you've got to waste too much time finding the stuff. Okay, so without further ado, we will do concept of limit today. Okay, so as I said, 2.1 is all about the basic stuff for me. It's all about, I haven't even gone through differentiation yet. All 2.1 is all about limits, understanding differentiation, and also lastly is your first principle differentiation. Then in 2.2, 2.3, we apply, okay, we know the formula for differentiation. Then we apply how to find maximum minimum value. We apply how to find second derivative. We apply and we see how to find gradient of tangent, gradient of normal, equation of tangent, equation of normal. These kind of things you will hear later on. Then further on, we learn rate of change, approximation, small change. All these things are the ones that we're going to learn after this. But today, 2.1, we'll focus only on the main part. All right. So concept of limits, right? Concept of limits is it's a very simple topic for y'all, okay? Because y'all learn not much for concept for limits. There are two kinds. I will summarize into two kinds. One kind is you use substitution. Wait, you just substitute, factorize and substitute. Wait, one you need to factorize, then substitute. Another one you need to factorize and substitute when you have x approaching anything, okay, but not infinity, okay, not infinity. And then if x is to approach infinity, normally what you want to do is, right, you want to divide every single term. The method is to divide every single term with the highest power, highest x power, or maybe y power, depends on what is in the limit here. I just say power lah. You don't have to memorize this. No, don't need to memorize. Okay, you do enough, you realize one, because this is not always true. So you understand, it's not always true. This is just like a guidance for you. Okay, so we look at questions. Okay, 1a, it is not approaching infinity, right? So I'll try to factorize if I can. How can I factorize? Always try to factorize. Why I need to factorize? You might want to ask me, why can't I just substitute x equals to 1? Okay, you see what will happen now. When I substitute x equals to 1, right, what will happen is I'll get, okay, 1 minus 1 squared divided by 1 minus 1. I will get 0 over 0. And you know 0 over 0 is not equals to 1. Don't ever forget that. You might think, oh, it's the same thing. I'm dividing the same thing. So I will get 1. No, that doesn't work for 0. 0 is an outlier for many cases of maths. Okay, so 0 divided by 0 will give you, you will get undefined. Okay, you can, it's not mathematically correct. It's undefined mathematically. Okay, you cannot define what is 0 over 0, or it's a maths error if you if it's a maths error if you type it to your calculator. 0 divided by 0, you shall get maths error. All right, so this is why we need to do something about it, because basically, right, when you see your denominator, right, when you see a denominator becomes 0, when you substitute this one inside here, before you do anything, like before you factorize or anything, you know that this is not correct. You've got to do something about it. And usually for this kind of cases, you factorize, okay? Because it's not infinity, so you factorize. So what you do while factorizing is you continue, you factorize. What you get is, I'll try to make it bigger when I'm solving this question. You have limit of x approaching 1. And this is how you mention it. This is called x approaching 1, not x equals to 1. Because x equals to 1, they'll give you the equal sign. X approaching 1, what? Of what? And there's no equal here. Don't forget, when you have a limit next to it, you just write the function next to it. So factorize the top, factorize the bottom. Bottom cannot be factorized any further because 1 minus x. Top, you factorize x out. Basically, you divide every term with x. Okay, you divide every term with x. So I take x out, so I divide the first term with x, I get 1, because x divided by x gives you 1. Basically, what I do is I divide by x, okay? So the first term I divide by x, I get 1. The second term, x squared divided by x, what I get? X squared divided by x, I get x only, okay? Why? Because x squared divided by x is x to the power of 2, same base, different power, remember? Logarithm minus 1 equals to x power 1, which is equals to x only. Okay? Until this stage, I wouldn't stress too much on all these things really, okay? All these things on how to factorize, how to solve the powers, how to do indices, all these things you have to go through my previous videos on indices and logarithm, or your school notes or whatever it is. Do enough practice before you reach here. or if you really need help in the basics, foundation, operations, these kind of things, you can always inbox me and I'll go through with you if I have enough demand of it. All right. So what I do now is I have x times 1 minus x after factorizing. How to check whether you factorize correctly or not? You type multiply back inside. Do you get back the same thing as top? Yes, I will get back because x times 1 gives you x. Then minus x times x is x squared. X minus x squared is same as top one. All right. So this is how I check, right? All right. So the bottom you cannot factorize, so you just put 1 minus x. And you realize there's something exactly the same. You realize that this thing and this thing is exactly the same. Okay, it's exactly the same. So when you have something exactly the same, right, what you do is you can cancel them. Okay, you cancel them. So what it will give you is you have limit x approaching 1 of x only. Because this thing, when you divide the same thing, it gives you 1, which you don't have to write. Okay, so when limit of x approaching to 1 of x, of course, you know that when you reach this stage, you just substitute x with 1. Okay, you just substitute x with 1, and when you substitute, you don't have to write the limit anymore. You just write 1 enough. Okay, you don't have to write limit x approach to 1, 1. No, it's wrong, because once you substitute inside already, you don't have to write the limit out anymore. So I have to answer 1. Okay, it's quite easy. So as I said, I discussed the circle questions only. Okay, B. You have limit of n approaching 3. Okay, not negative, not infinity, right? You haven't seen an infinity, right? Infinity you see down there. Okay, infinity, you see infinity. Question 2, infinity. Question C, infinity. These are under question 2 later. But now we solve question B first. Okay. So when it's approaching something and you realize that when you substitute inside, you get dividing 0. Whenever you see something dividing 0, you know you cannot do it this way already. When you straight away substitute inside, you get negative 3 plus 3 as in the denominator, because negative 3 will sit on n. Plus 3, it gives you 0. Okay? So anything divided by 0, you know it's wrong already. Okay? So anything divided by 0 is wrong, so you need to factorize. What you do when you factorize is write back limit n approaching minus 3. Factorize. Bottom cannot be factorized any further. Top can factorize. How do you factorize the top? Use your calculator. How to factorize quadratic. Okay, factorize, you shall get n plus 3, n minus 2. Okay, divided by n plus 3. If you do not know how to factorize this one into this one, you can comment down. I might make a special video on quadratic, on how we do quadratic. Or maybe I'll just go through in quadratic chapter. So just wait for it, it will arrive soon. Okay, but quadratic chapter is not very tough, so I wouldn't do it first. It depends. I'll see what's the demand. All right. So what I have now is I have something that I can cancel. You see, not the idea is to actually factorize until you can cancel the denominator. Because once you cancel the denominator, right, you don't have to substitute negative 3 later because it's gone already. That's the idea of this limits, okay? How to do the tactic to do it. So what you get limit of n approaching minus 3 of n minus 2. Okay, then after that, when you have something like this, you know that there's no problem really because there's no denominator anymore. You can straight away substitute and get a number. So you can just straight away substitute and get a number. So minus 3 sit into n. So what you get is minus 3 minus 2 equals to minus 5. Okay, when I get a number like that, then I can straight away substitute. Even though it's approaching, you straight away substitute, you get the answer. But why I cannot do it on this step? Why I cannot do it on this step, substitute? Because I said already many times that you will arrive with a denominator which is 0, which is very bad. On top, I can be anything. It can be 0 or non-zero, it doesn't matter. But when you arrive with a 0 on the bottom, you know that this is wrong mathematically. So you cannot use this method of straight away substituting. You need to factorize first. That's what I did. Okay. Basically, I said here why you cannot straight away substitute negative 3 inside this n. Because you get a 0. And I don't care whatever is on top. Whenever bottom is 0, this one doesn't work anymore. Okay, that's why I factorize. I made this n squared plus n minus 6. I make it into n plus 3, n minus 2. Why I do that? So I can cancel the n plus 3. If you see, I cancel the n plus 3, cancel them. So you don't have to substitute the denominator with negative 3 to get 0 anymore. Therefore, you won't get a 0 in the denominator. I try to explain longer a bit so that because you're doing it for the first time, I try to explain again and again and again so you get into your head. Okay, I won't discuss every question. The rest you can do. And I have a plan, right? Actually, I have a plan to I'm slowly creating a Facebook community, right? If there is enough of you in this Facebook community already, then what I can do is I can release answers for those questions which I didn't answer. I can solve the solution. Then I can include the solution into the Facebook, all for free. I don't know no such thing as membership charge, whatever it is. No, I want to create open group for you all to join, so that I can actually include the answers for the questions that are not discussed yet into the Facebook systematically, so that you all can also view the answers. Because I did not attach the answers down here, I think. Yeah, I wouldn't yet. Okay, as I said, let's see first. For this question G, can I substitute 1 straight away? You try and see. Just check the denominator. Don't have to check the top. Just check the denominator. Can I substitute? If I substitute -1, okay, what I'll get is just check the denominator. If I substitute -1 into x, I'll get -1 squared minus 3 times -1 minus 4. What I'll get is 1, because -1 squared is 1. Anything negative you squared, it will still be positive. Doesn't matter. So negative, positive, 3 minus 4. And you realize you get 0, which is no good. Mathematically, it's no good. No good. Okay, no good. So what you do is, as I said, the trick to do it is to factorize, and cancel. Okay, but this one you must realize, you must understand that the top can factorize, the bottom also can factorize. So factorize everything. Okay, so you have limit, as I said, copy back the limit approaching -1. Top, what do you get? You factorize using a calculator, you get x plus 1 squared. Okay, x plus 1 or x plus 1, x plus 1. Or you can just straight away write as x plus 1 squared, because they are multiplying each other of the same thing 2 times. So I write x plus 1, or x plus 1 squared. I'll just write x plus 1 squared lah. Yeah, divided by x minus 4, x plus 1. I can do it because I've done enough mental factorization. If you do not know how to get this one immediately, use your calculator, it doesn't matter. Even though I do encourage students to actually learn how to mental factorize. Okay, it's quite cool, okay? Wherever you go, right, when you see stuff like you just tap the calculator, I sure you know it's x minus 4, x plus 1. Isn't that cool? But never mind, it's all right. Okay, and you see, you have exactly the same thing, and this power 2, power 1. And that reminds you of your indices chapter. When you have exactly the same base, what? This whole thing's the same thing, what? But different powers, you can actually minus the power. Okay, 2, you can actually minus the power. So actually you can, basically, in other words, you can actually cancel this x plus 1 and this power becomes 1. Why I do that, I explain to you why. Because this is actually, right, this one actually you can write it as x plus 1, as I said many times just now, x plus 1, x plus 1. So if everything is multiplying, dividing, right, you don't see any plus minus, right? You can only cancel stuff when you see times and divide only, times, when you see times, okay? When you see plus and minus, don't do it now. This is a very important thing I want you to take note if you are taking note now. When it is plus and minus, don't forget, when it is plus and minus, you apply this rule. When it is plus and minus, apply this rule. A plus B over 2 is equals to A over 2 plus B over 2. This one is correct. But 2 over A plus B is not equals to 2 over A plus 2 over B. This is wrong. You apply this rule, you apply this thing, and then you try to, this when you have plus or minus, okay? When you have plus or minus, okay? Plus or minus. Then you apply this thing. But this one is all multiply and divide. You might ask me, oh, there's a plus inside the bracket. So what does it mean? I don't understand. I'm very confused now. Don't worry. As I said, when you see a bracket, right, imagine them as one thing. Imagine them as A times A divided by B times A. Imagine them as one thing when you see a bracket, you understand? Because bracket is a family provider. It's providing this whole thing into a family, you understand? They are not separated outside. They are in a family. They are like one term, not one term. They call it as one unknown. It's something like one unknown. It's like x plus 1 times x plus 1 is something like A times A. No difference. You get what I mean? So that is the idea. You must understand that when there's a bracket, they are like together. They are like, you can treat them as one thing. Don't be scared of the plus. Okay. What I'm trying to say, if you have open thing, open something like x plus 1 minus 3 divided by blah blah blah. X plus 1 minus 3x squared divided by 4 minus x squared. Can you separate into? I don't know how you want to separate. Can you cancel? Cannot now. You cannot cancel like this, okay? Because it's separated by plus and minus. You can only do that when it's times and divide. Okay, so you can cancel actually x minus 1 and x plus 1 and x plus 1 is exactly the same. You can cancel them. Okay, so what I do now, I'm left with limit of x approaching -1 of x plus 1 divided by x minus 4. Okay, now can you cancel or not? Cannot now. Why? Because now right, there's no multiplication. The thing you are canceling, right, must be separated by multiplication or division. For example, you want to cancel x and x. You must understand that the function next to x is actually not multiplication. You cannot do it, you know. You see, it's not multiplication. How you can factorize, how you can cancel is when you have x multiplied by 1 divided by x multiplied by 4. This one you can cancel because it's times. This is plus, so cannot, and minus. So you can cancel this one. If it is not, you don't do it. You understand? Okay, so now you check and see. You substitute, do you still get 0 in the denominator? You check. So this one is actually going to be, when you substitute x with -1, you get -1 minus 4. You get -5. So you don't get 0, okay? You don't get 0 means it's a good thing. Good. Okay, so you can straight away substitute actually. You get limit of x approaching -1 of -1 plus 1 over -1. No, you see, I'm making a mistake that I told you not to make. Whenever you're substituting, don't write the limit. You see that? I'm making a mistake, so you please do not repeat my mistake. Even I still make this mistake sometimes, okay? Because I'm not focusing. So you should always substitute what you get. You have -1 plus 1 over -1 minus 4. This is 0 over 5. Okay, you might ask me, 0 on top can or not? The answer is can, not the bottom can really. Okay, top can, bottom cannot. You understand? Bottom cannot, top can. So whenever you have 0 divided by 5, what you get is you just get 0, because 0 divided by anything will give you 0, except for 0 divided by 0. 0 by 0 does not give you 0, okay? You understand what I mean? So you remember, I tried to write somewhere here. The important thing I tried to write in green. I find you got green color or not. Okay, got. Okay. 0 divided by anything is equals to 0. Anything divided by 0 is math error, undefined. Okay, including 0 divided by 0 also. This one you can take note. Okay, I just leave it here. So we are done with G. Now we go to question 2. Why on question 2? Because it's a different kind of question. Now the limit is approaching infinity, if you realize. If you realize, right? Wait, let me change back the colors first. Okay, because now it's approaching infinity. So as I told you just now, the second kind of question, if it approach infinity, you got to divide off the term with highest power. What is the unknown you can see in this thing? C, right? What is the highest power? This is C power 1, this is C power 1. So the highest power is 1. You understand? If you have C2 here and C1 here, the highest power is 2. Excuse me. But the highest power is C1 and C1. So the highest power is 1. So what you do is you divide the top with the highest power. What I do is, you see, I have limit C approaching infinity. The top, what I do is, you see, you have 3C over C plus 2. I copy back everything. So the top right, what you do is you times 1 over C. Basically, you divide, or I don't say times 1 over C, I divide with C. Bottom also I divide by C. Why I divide by C? Because C is the highest power unknown. There's a reason why I do it, okay? So what you get is, you get limit C approaching infinity of 3C divided by C will give you 3 only, divided by C divided by, okay, when you have C plus 2 divided by C, right, this is the bottom, what I'll get, let me rewrite, this is the bottom, what I'll get is, okay, remember I told you, when on top plus minus, you can separate it into C over C plus 2 over C. I will give you 1 plus 2 over C. Okay, so it's 1 plus 2 over C in the bottom. Okay, so now I reach this stage, right? The idea is to reach this stage where you substitute infinity into denominator. Okay, remember I told you just now, right? N over 0 is undefined, right? We don't like this. Undefined means we don't like it. We want to find another method. We don't want to face this thing. But when I have anything divided by infinity, we like it. Because it will give you 0. Okay, you must think of it. Anything divided by infinity will give you 0. Okay, but infinity over infinity is not. Infinity over infinity will give you undefined. I want to summarize this for you later. I'll summarize this for you later. Okay, so far what we have done is, I'll write in green later. I'll write in green later. This for the infinity part. This for the infinity part. N divided by infinity gives you 0. Infinity divided by infinity gives you undefined. Okay, I write in green color so you can match with this one. This green color you must take note. Later maybe I'll summarize for you. Okay, what we learned so far is 0 divided by anything will give you 0. Okay, n divided by 0 will give you undefined. Okay, then we look at the infinity part. N divided by infinity, basically you divide by infinity, you get 0. You divide by infinity, you get 0. Why? Because right, you are using a number like 2. Divide with such a big number that is so big. Infinity means it's theoretically it's a very, 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 it's the largest number. Okay, so you take 2 divided by such a big number, of course you get 0. You understand? Basically, you think of it this way, like I have 2 sweets or I have 1 sweet. I'm trying to divide to unlimited amount of people. Yeah, I've got like 1 apple. I divide it to unlimited people. Basically, the people are so many until you cannot finish counting. How many part of apple will one person get? It's approaching 0, right? You won't get anything, right? Because there are too many people to share with. You understand? That's how you can think of it. You understand what I mean? So you will get 0. Each person will get 0. This is one of this. This is trick 1. I want you to remember. The green color one, remember, right? In green color. So actually, right, what we want to get the answer is to get it in terms of something divided by infinity. Okay, so you see why we do this. We look back here, why we want to divide everything with C, why we want to divide with the highest power, so that we can achieve something like this. Can you see? 2 over C. Why? Because now what I do, right, is equals to, remember now I substitute infinity straight away inside here. So when you substitute infinity inside, you know that, okay, we see here, 2 over infinity, I will get something like this. I'll get 3 over 1 plus 2 over infinity. Correct enough? Because I substitute C with infinity. Because this one has no C, this one has no C. I only substitute the C with infinity. And this one, I know the value. I know it's 0. Why it's 0? Remember, imagine you're actually dividing 2 apples to infinite amount of people. You're dividing the 2 apples to infinite amount of people. One person will get no apple. It's because there's infinite people. You get what I mean? So you get 0 here. You get 3 divided by 1 plus 0. Why 0? Because as I said, 2 divided by infinity will give you 0. Okay, so this will give you 3 divided by 1 equals to 3. So you must see the idea, how to solve questions with infinity and normal questions like above. Like the top one, right? When you can factorize, you factorize, then you can cancel. Okay, why you want to cancel? Let me summarize it somewhere up here. I summarize a bit up here. You write down yourself in the notes. We talk about the top one first. Why we want to factorize? This question 1. Question 1 is we are talking about question 1. Why you want to factorize? Question basically is this question number here. Okay, question 1 here. Why you want to factorize? Okay, you can be answering me now already because you want to avoid bottom 0. I hope you understand what is bottom 0. Basically, denominator to be 0, something over 0. We don't want this one. We don't want this one. Okay, we don't want this one. Okay, so how to avoid that is by factorizing lah. Because when you factorize, right? When you factorize, for example, you can cancel off the denominator, so you don't have to substitute anything to the denominator later, and it won't give you 0 lah, because it's gone already later on. Okay, that's the idea. Why we factorize, and then we cancel, factorize and cancel, so we can avoid bottom 0. Okay, this is normal question. Then now is the infinite question. The infinity question. When you have something approach infinity, right? What we want to do is to divide with highest power, unknown. Okay, why you want to divide it? Because we know that n divided by infinity will give you what? N divided by infinity will give you what? N divided by infinity will give you 0. This is something you must remember. Okay, I better write down nicely first all the tricks. Okay. Let me see where to write. I'll write it in the next page later after I'm done with this first. I'll try to add one page first. Current template. Okay, so far what we learned is 0 divided by n is equals to 0. And then n divided by infinity is equals to 0. Okay? You remember it like this, or we don't write like this, we write something like this. 0 divided by n divided by 0 is equals to undefined. Then we have infinity. Wait, let me think how to say. Then what we have is n divided by infinity. Let me think how to phrase it. Gives you 0. Don't forget this. Then infinity divided by infinity is undefined. Okay, this one 0 divided by 0 is also undefined. Okay, so don't forget, many people think these two as they will give you 1, they don't give you 1 because they think that the same thing cancel 1, 1. No, it's not like this. Okay, it's undefined. Okay, there's no way to define it. So remember these few things that I teach you down here. We're using these tricks to solve actually. So we are done with A, we are done with A. Now we try to do D, okay? D, how do we do D? Let's see. Okay, so it's infinity, I see. So I know that I'm going to divide with the highest power. You see x only, right? So x, the highest power is 1. So what I do is, I divide all the term with highest power. What I do is I divide with x, I divide with x. Okay? When I divide with x, I can write it as I times 1 over x, same thing. When I want to divide by 2, it's same thing as times 1 over 2. It's the same thing. Okay? Why is it working this way? You try to figure out yourself. Try to think. You try to divide by 2 and times 1 or 2. Do you get the same answer? To test it out. Okay, so once I divide it already, right? So the top, what I have is I have 3 plus 2x divided by x over 4x plus 1 divided by x. Basically, I divide x top and bottom. Why I divide by x? Because I told you I want to divide with the highest power unknown, which is x to the power of 1. Okay, so now what I have is I have limit of x approaching infinity. What I have, okay, remember I told you, whenever you have plus on top, you can separate it into this one plus this one. You can separate it into 3 over x plus 2x over x divided by 4x over x plus 1 over x. Okay, then what will this give you? Is limit of x approaching infinity of, you can cancel certain things. 3 over x, you cannot do anything. Plus 2x over x, you can cancel the x because multiplication between them. 2 times x divided by x. So I get 2 only divided by 4x over x, can cancel the x because it's multiplication here. So it's 4, I get 4 plus 1 over x. Okay, now I've arrived to this stage. Why I want this stage? Because I know that if you substitute infinity inside now, because I know I'm going to substitute infinity later. Once I substitute infinity now, these two will become 0. Because I told you anything divided by infinity will give you 0. Except for infinity divided by infinity. So I substitute now. So 3 divided by infinity plus 2 divided by 4 plus 1 divided by infinity. Okay, basically I just write this. Then what I get is this one will give you 0 plus 2 over 4 plus 0. It's 2 over 4, which is equals to 1 over 2. I simplify. Okay, so that's very simple. Basically, what I did is I want to achieve this. You see, for these two techniques, right, we want to achieve something. We want to achieve something like this for infinity case. We want to achieve bottom to be x. You understand? We want to achieve something to be bottom to be x, so I can substitute infinity in later and get 0. But for the top right, different. The top is what I want to do is I want to avoid bottom to have 0. So I have to factorize and cancel. That is the idea for these two different cases. Okay. So that is actually it for this limit. That is roughly your syllabus for limit. Nothing much. It's very simple if you know what to do. Remember, if you see numbers, if you see x approaching a number or 0, don't forget factorize, cancel. Factorize, cancel to avoid denominator to be 0. To avoid denominator to be 0, you don't want denominator to be 0. So you try to factorize and you cancel the denominator. Let it disappear. So you don't have to, so you won't get a 0. Let it go away. You understand what I mean? But for the bottom one, it's different. For question number 2, right? what you're trying to do is the tactic is to try to divide with the unknown with the highest power so that you can substitute infinity into the denominator like this. You see, you substitute, see this 2 over infinity. When you substitute infinity into x, 2 over c. When I substitute infinity into this c, I get 2 over infinity. It will give me 0. That is our idea. We want to get something like this, something over infinity. Then it will give us 0. For example, this one, 1 over x will give me 0. 3 over x will give me 0 when I substitute infinity into x. Because as I said many times, something divided by infinity will give me 0. All right, so I don't want to talk too long already. These are the stuff you can write down. You can compile yourself if you learn something new somehow. All right, so this is all for this subtopic of 2.1. I will wrap up this video with just this, okay? So the next video would be on differentiation, understanding on differentiation, what differentiation actually means, what it will give you. And we look at it in a graphical perspective, right? So with that said, I wish you all the best studying and good luck. We stay safe until we see each other in the next video. Stay tuned. Bye.